Hangout. My name's Peter. Glad to have you with us tonight, or whenever you might be watching. Whether you're watching this live or after the fact. Thanks for tuning in, and hopefully we can get somewhere interesting, and get something cool put together here. Tonight on the stream, basically the idea is that we're going to do some more procedural modeling. We started last week with doing some basically some like fungus that would be growing on a tree, more or less. And so we're just kind of starting to get the idea of that, and then we'll start to kind of copy these little fungus growths around, make some randomization, things like that. Obviously, we're going to be relying heavily on attributes to drive the way that the geometry is created. It's really one of the ways that you can best use Houdini to, to create some sort of geometry that might be, hard to create otherwise. The procedural nature of the modeling is the strong suit of Houdini, and so being able to kind of set up parameters that will adjust certain things on our models, setting up ramps and maybe using different ways to kind of interpolate between properties is obviously, like I said, the strength of Houdini. So that's what we're going to be doing tonight. Continue a little bit on with that. Hopefully we'll get something interesting before the end of the evening. And the idea came from our Discord server, and it was the idea of like, hey, how could you do some growth like this on a tree? And so what we're going to do is first obviously make these little fungus growths and then do some animation on them as well. The way that I tend to like to do, I guess you'd call it procedural animation. I like to use like a start frame attribute and set a width that start frame attribute will that will kind of go like a little window kind of that'll go past the frames or the different attributes and look at them and say, is it within this window? And if it's on this side of the window, it'll be 0. Maybe on this side, it'll be 1. And then in between, it'll interpolate somehow in between them. So that's kind of how I like to do, modeling or animation like that. As opposed to using keyframing and stuff like that. It just feels a little more flexible in some ways. You don't have to dive into curve graphs or curve editors and things like that and start messing around with them in there. Just a little bit more, maybe a little bit more technical. It's a little bit more maybe the way that my brain works, but I just like doing it that way. I saw a talk a couple of years ago now at SIGGRAPH, and they were talking about how they did that, the same kind of concept for stuff in Frozen, and I think it was mainly people from Disney Animation talking about using Houdini for that type of animation. So it was really interesting, and it's been something that's kind of stuck with me over the years. Honestly, I mainly used Houdini for effect stuff, as I'm sure most people, it's kind of why you see Houdini and want to start messing around with it, because of seeing amazing explosions and things like that. But that was mainly what I did in my studio job for years, was effects based stuff. But now that I've been playing around with it a little bit more just on my own, giving myself ideas and things like that, I've started doing that a little bit more. So so anyways, that's what we're going to be talking about tonight. Why don't we, before we get too far into just continuing on with where we are, why don't I do a quick recap just to kind of talk about what the, what it is that we're doing, and we'll just kind of go from there. So let's take a look at that. And so here's the scene that I was working on. And this is is kind of the image that I was using as a starting point here. So we're basically trying to make like little little fungusy growths that are going to be on some sort of tree branch, with these little kind of flat stumps in the middle. In fact, that's probably too tall now that I'm looking at it again. I was just kind of doing this quickly last time, but obviously we can easily adjust that. But so I've kind of started going with these little spines here that are kind of the inside of these fungus growths. It's not going to be exact. It's not going to be 1-to-1. I'm not trying to do anything that's like, this isn't going to be the perfect thing or whatever. There's probably quite a bit of R&D that I could do to figure out the best way to do, maybe mathematically figure out how to make these branches as good as possible. But there's certain, we can certainly figure that out over time. You could obviously put a lot of time into getting all of these individual details and things like that, but we're just going to try to get something here and scatter it on a tree, like I said, and then see where we can go from there. So that's kind of the reference we're trying to hit. I'll just minimize that. And so we have this little like fan shaped thing. So first of all, we had this little stump, and I just kind of made this little poly bevel thing. Did an edge divide for the bottom just to kind of give it a little bit more room there, and then just kind of made it into like a little mountain. Used a mountain sop to kind of deform these points in their normal direction. So that is the little stump, I guess you could call it. I'm gonna actually, let's try this here. Let's go to the tube and let's make that a little shorter actually. So maybe like that would be good. Cool. Yeah, just a little shorter. Didn't need to be quite so tall. And so then on this side, I started out with a circle, and I'll just template that stump. And so we've got this circle, and depending on the points here, we're going to calculate a few things like this orient along curve. This is going to set, I believe, an up and an n vector. So instead of out, we're going to look at up. So this is the up vector here, right? That's going to be coming out of these points. And we're also going to use the normal as well, which I believe is pointing, like tangential to this curve. So in this case, we're using the up vector to kind of copy where these points are going to go to. I'm also using this resample here just to add a curve view attribute. And then on this attribute adjust float, we can adjust the p-scale. And so when we copy this line onto, which is just literally 2 points, we copy that using a copy to points, we get this kind of fan-shaped curve. And that is actually coming from this remap here of the p-scale. So that's changing how these are coming out. We could also take this, we could do another attribute adjust float. I really like, this is kind of these came out maybe a couple versions ago. They started building all these attribute adjust nodes. They're just really nice because they can do some quick stuff that you could obviously do in Vex as well. But, it's really nice to not have to, overly think something as simple as just maybe randomizing an attribute, When it's just something like this where we want to add a little bit of noise into it, we can take an operation here like an add. We can add some noise in here with the pattern type. You can see this is already starting to kind of take effect. And because it's set to p-scale by default. And what we can do is make sure that this is, we can just kind of go through here and make sure these attributes are the way we want them to. We could say minimum value is -1, maximum is 1, or we can do something like a middle and range length. So we could say 0 is the middle, and then this will be our kind of range that's going to get added into it, right? So obviously we could go crazy with it, or we could just do a little bit. So like maybe like 0.25, something like that. And then if we take the element size and reduce that, that's going to just change our noise around here. And you can see how that's affecting it. So maybe we do this at like 0.25, something like that. Maybe this is even too big, maybe like 0.15. So just something like that is just to kind of make the edge a little bit more interesting. So then we can take this resample here and go with the point vop, and that'll curve up these ends. And what this, so this resample here is set to, oops, lost my template geometry there. This resample is just set to adjust the length to, to set an equal length between each point, which is set to 0.05. And then this point vop is going to start doing some manipulation of these curves so we can get them to maybe do something a little bit more interesting as they kind of go straight out, so that they're not just straight lines, but they have some noise to them. They also are curling a little bit at the ends. You can see here we're getting this little bit of curl across them. So with that, I promoted a couple parameters here. You can see there's a vein curl ramp, and that is literally just driving. We're taking the curve U of each of these individual polygons that have a bunch of points. We're running that through this curl ramp, or this ramp parameter, and then multiplying it by a scale, which this is just a promoted parameter as well, which says vein curl scale. And then we're just adding some noise into it as well, multiplying this, adding some noise. We can also change the amount of noise here as well. So if we turn this down, that's gonna have no noise, and if we went crazy with this, that's gonna have a lot of noise. So we can kind of adjust the noise here, and that also we could promote that parameter. So if I middle click on it and say promote parameter, and then you can just kind of adjust this here. We can just say max noise amplitude. There we go. All right, so now that'll be promoted up as well, and we can adjust that and kind of slide that around and see where we might like that. The vein curl scale is basically just a scale on this curve, so we can just kind of adjust that as needed as well. And here's our vein curl ramp. So if we want this to curl differently, not that we would want this, but if we wanted to pull this all the way back, we could. You can see that this obviously has, we have this ability to kind of adjust this across the length of these individual little curls here and stuff. So, yeah, that's pretty, and we can expand this as well so that we can get this looking the way we want it to. So maybe we wanted a more pronounced curl at the end. Okay, so we're starting to get somewhere with that. We've got some randomness on these individual, kind of spines coming out, and then we're just using a polywire here to give it some geometry at the end. Which we can do it that way. We could also use a sweep. That would be a simple thing as well. I can't remember if we did this last time or not. Yep, so this is erroring because we have second input cross section, so we'll just do a round tube here. We can change the radius. So this could be faster as well. There's a million different ways that obviously you can go about doing each of these steps. Polywire, this has good UVs, so this might be something that you'd want to do from that standpoint. This is not giving us UVs, so that's obviously not you could compute them, but they're probably not going to be as good as this polywire UV is going to be. This is a newer node that has a little bit better UV setup. So, just something to think about. Doesn't really matter. Maybe we'll just use the sweep because it seems to be a little quicker. So we'll just maybe use that instead. I'm just going to turn off the UVs because we really don't even need them right now. So there's that. Let's just see here. Let's do end caps. Sure. Just look at the difference here. Oh yeah, that's actually what I would prefer. Something like that. Cool. All right, so we've got these set up. So that's where we're at right now. We've got these merged together, and we're starting to make our little, random fungus things that are going to get copied. And I should also say that we have a tree that we had set up. Oop. Interesting. I don't know what that's all about. Um, so we have this tree branch here, and we have some copy to points that we've done as well. And we were just copying simple grids just to see how that will kind of play out when we have them attached to the tree. So we have this tree trunk, and we have these kind of copied to it right now. So that's going to be where these individual little fungus elements will live. So just so we can see how that's looking. And here's our mushroom. We're making this at like unit scale size roughly. I'm just kind of eyeballing it for right now. And probably at the end, what I'm going to do is use the match size to scale it to a 1x1 cube. Actually, maybe it'll be a 2x2 cube so that it's a 1 meter radius. And what that'll help is when you have your scattering and you're trying to keep your points, if you're relaxing your points and things like that around each other and trying to keep them away from each other, having that unit sphere is pretty standard for doing relaxing and stuff like that. So it's kind of like the easiest way to make sure that they're not going to be overlapping and stuff when you're doing relaxation and stuff like that on scatters. So it's just something that I've noticed, and it might be something I'm doing wrong possibly, but I just noticed that seems to work pretty well. So I've been doing that with my, when I'm doing copy to points and doing scatter and align and things like that. So yeah, just something to keep in mind with this whole setup. So another thing I should say, as I usually do at the beginning of any stream, is, if you have any comments, if you have any questions or thoughts, please put them in the chat. There's no stupid questions, and there probably is quite often stupid answers from me. So, I'm certainly not the end-all expert in Houdini. I just really enjoy teaching and learning and getting better at doing computer graphics, and whatever I can kind of learn new, I love. So just don't feel like this is just me explaining how to do something. You can always drop a comment in the chat. I love to be able to, kind of interact and have some dialogue as things are going here. So please feel free to, and don't feel shy. I'd love to hear from anybody if they have thoughts or suggestions on how to do something better, or questions as to why I did something. Happy to stop and answer those questions as they come. So so that's just a little caveat I like to give out. Sorry, I'm just enjoying my coffee here for a second, so give me one moment. I have this lovely mug that is a design that my wife did. She's a graphic designer and she does cool designs. So yeah, if you ever need to hire a really good graphic designer, I know one. So hit me up and I'll get you her information. But she's good, so she's not cheap. So be warned. All right, so let's look at what we've got going on here. So the thing that I was thinking about is that we have kind of this like membrane that goes across all in between all of these, individual kind of, veins, I guess. So I'm thinking that is going to be something that we want to have in this little model that we're making. So let's try that out. I believe, I can never remember which one's which. There's Polyloft and Polypatch. Let's try, nope, I don't think it's going to be that one. I think it's Polyloft. Let's try this. So what we're going to do is try to connect these all together. So what I'm going to grab this before it's geometry, when it's, or not geometry, but before it's polygonal faces and things like that, when it's just an open poly wire. And let's drop this in here and see what happens. Oh yeah, look at that. Wow. Good Lord. Sometimes things are just too easy. Awesome. Um, yeah, that's pretty simple. So there's a couple different things that we can do here to adjust how these will kind of be formed. I think it's basically trying to minimize certain distances here when it's building these. What do you call it? These triangles and things like that on here. So that will be super helpful, and we'll use that. Let's also do, you know what I really like? I like the thicken. The labs thicken is a very nice little node here. Oh, you know what? I'm going to save this as a new one just so I have this separate. Okay, great. So now we've got this thicken. Oh yeah, look at that. Way too thick. So thicken is really cool because it will just take obviously your flat geometry and just extrude it. But it does it in a really. Whoa! What did I just do? I just freaked the. I just did something really crazy with the viewport. I don't know what that was. That was weird. It's like I barrel rolled or something for a second there. Anyways, so here's thicken, and we can do it in both directions as well. So here it's going to, it's going to start from that center point. And if we click this off here, we can see that's the middle edge that it starts with, right? So it goes up and down in this case. So let's make this a bit thinner by quite a bit, maybe 0.01. That'll be a good depth for it. At least I think. We'll try that. And let's merge that in as well. We can start to see how that's looking. So yeah, we're getting there. We're getting something that looks similar to those, to this geometry that we are kind of trying to go for here. We're starting to get these, the veins and the membrane that kind of connects them all together. Now, the real difference here is that there's actually veins that start in the middle out at the ends here. We're not going to do that. We're just going to leave it the way it is. But something interesting you could always kind of keep going and playing with and see what you could kind of get from that. But let's change this to smooth shaded just so we can look at it without all the lines and things like that. So that's kind of cool. And the nice thing here is that, again, because it's procedural, we're going to have all of these things kind of flow through our geometry, right? So if we were to come up here and say change something with this, the way that this curve is, right? We could, let's make this a little bigger. And if we brought these out more, it's just going to all flow together, right? So they're starting to get smaller there. Maybe this is coming in like this. If these get shorter, everything is going to follow along with each other, because they're all using the same geometry to create all this stuff. And these edits that we make are going to flow through the network and come down here to this at the end. So that is looking pretty good. Actually, I'm going to make this maybe just a touch 0.75, maybe just a touch thinner, just so these veins are a little bit more pronounced. And let's see. What was I just thinking? Oh, let me just open Photoshop by accident. My bad. There's something I was thinking with these. Oh, yeah, maybe they should get a little smaller as they go down, I think. I don't know if they get smaller per se. Okay, just close. I don't need to have you open right now. Thank you. Yeah, but maybe what we could do a couple different things here. We could take these and we have scale. We can apply scale along the curve. I'm just looking to see. Hey, Jamal, thanks for joining. Yeah, thank you so much. Yeah, it's just something simple I was working on last week and just kind of continuing along with, with the animation or with the modeling. So, Yeah, I'm going to just trying to think of where that comes from, or maybe polywire UV will be better because we can scale this a little bit easier. Yep, there is a width attribute there. You know, let's just do that. That'll be a bit easier because we can set attributes here, and this is actually going to, even though it takes maybe a second longer um, to kind of process and everything, we can at least um, get some scale along these individual elements. Let's just look at this here, see how that's looking. Cool. All right, get this out of here. All right, so I'll just keep this. So let's use a width attribute here. Now there is no attribute, so let's just call this width, and let's apply a width attribute on here again. So let's just look and try to visualize this. Do I have curve view? Yep. Just want to see that these are all, yep, for sure. They're set to 0 here at the end, so that's a 0. And it looks like we're going all the way down to 1 at the tip. So that's perfect. So we have that attribute already, and we can use that again to drive the width attribute. So let's just do another float attribute, adjust float. We'll drop this in here. This is going to make a width. And again, this is I think a really nice way to have a remap attribute here from using curve view. And if we come down to this polywire, we should start to have, yep, sure enough, they're changing in thickness. Now they're going kind of the wrong way. So let's adjust that. We can say from 1 to 0. I could also change this ramp if I wanted to. And so now we can adjust things like our minimum value here. So maybe we want it to be half the width when it gets to the end or something like that. We can do just 0.5. So now we have some thickness here that's coming in. And similarly, what we could do is we could do an attribute adjust float again and just add in some randomness. And what we could do that off of is we can use this curve number as our unique ID. Let's see if we can see that. So I'd set that up in this resample here. So there's a curve view and a curve number. That each of these curves gets one number, and each along them gets the curve view attribute. So let's do width here. And then what we can do is we can say noise, or we could say random. Doesn't really matter because these are going to be, I think, pretty different. But all right, so we've got this. We're going to maybe we'll multiply it just because we can kind of start out with 0 to 1. So we could make it maybe 0.75 and 1.25. So we'll have a little bit around 1 on either side. So it'll be a little bigger and a little smaller than what we're starting with because we're multiplying it. So let's do the randomization by custom attribute, and we'll say curve number. And what that should do for us, let's just click this and get our curve number. Yep, there they all are. You can see each of those have individual unique curve numbers. And similarly, if we look at width, we should be able to see the difference here, actually, with the color pretty easily. So you can see here that we're randomizing based on, which curve it is, right? And so we could do it random. We could do it with noise if we wanted to. The only problem here is this is actually going to try to do it by point. So that's probably not going to be the best way to do it. Now we could, where would that go? Yeah, that changes, I guess. So this is probably the best way to do it. We could adjust the randomization here with our seed number if we wanted to. Yeah, so let's take a look at what that looks like. Nope, I don't need the visualization there anymore. Turn that off. Cool. So now we're getting a little bit more, maybe natural looking elements from this, and it's actually looking like they're getting a little on the small side, and probably this surface could be a little thinner now too. Yeah, thanks. Yeah, it's a nice little way to get some to get a little bit of extra randomness in there. Um, it's always good to. I think that's one of the best ways to get these random kind of natural feeling elements is by using a random an attribute to drive the randomness. Um, whether it's a name, whether it's some sort of integer number or something like that, or a float, whatever. It's always good to have something like that you can use to randomize. So that's one of the nice things with the resample here, getting a couple of these like curve numbers and things like that. You could also use connectivity. That's another one that I use a lot to get randomization. The connectivity SOP will add a point or a primitive attribute called class. You can name it whatever you want, but by default it's class. And like that's a really easy way to add randomization too, because then each of your geometries gets their own each gets their own attribute, and you can do randomization from that. So all right, cool. So that's starting to do its thing, it looks like here. We can certainly figure out how we want to do this. Like maybe we do 1.25 here, and then maybe this goes to 7.5 again, so we get a little bit more of that randomness like that, so we're getting some of that. The only thing I don't love about this polyloft is that it's feeling a little too straight at the very ends here. So let's look at that and see what we can't do with that. Just thinking about that. I'm not sure about how to add some more into that. Let me think about that. Hmm. If I just, I don't know. Maybe if I just subdivide it, maybe I'm overthinking it. I don't think it's going to look good, but let's see what it does. Yeah, definitely not good. Oh, I should do that before the thicken. That's right. Don't want to do it on the ends. Yeah, that's not terrible. Crazy with it there. Yeah, that could be kind of interesting. Let me just see what this looks like. Smooth shaded, so we're not. That's, yeah. Hmm. Unfortunately, the problem is that because it's subdividing and it's smoothing it out in some of these places, right? And so some of these some of those wires there aren't exactly, you know, still in the same. They're not kind of on the center of this anymore. So I wonder if I could. Maybe what I could do is do array, possibly, and use this. This. Let me just see what that'll do. Okay, yep. Hello. That's not what we want to do. Not from normal. Let's do minimum distance. There we go. That might be what we want. Yeah, let's try that. Because now those will sit on there. Let's see. Yep. There we go. So what I did there was I used the ray node, which basically you can do it in two different ways. You can use it in minimum distance or project rays. So the problem with this is that I'm trying, in this case, I have normal, I'm using the normal attribute. And if we look at these and see what their normals are, they're probably either non-existent or funky. And sure enough, they're non-existent. There are no normals on these. So that's not going to be very helpful. So it's kind of freaking out. You could also set a vector, but what vector are we going to use? Because some needs to go up, some need to go down. So so instead of using that, I'm just saying let's do minimum distance. It's going to find the minimum distance between this blue geometry here, which is kind of the input on the second input here. That's what we're looking at here. Those are the collision primitives. And then we're using this to just basically find the minimum distance between the points and this surface. So now they're back right on that subdivided surface. And now when we do the polywire, go away, they're going to be right back where we kind of wanted them. And then we can merge it all back together and they'll be pretty much centered on each other like that. And that's looking a little bit better. We've got some smoother stuff going on here, which is kind of nice. The only thing I don't like is the caps here. Do maybe a couple more on those, maybe like 6, just a little bit. It's too bad I don't see use that. I don't see anything to set the caps, so I'm wondering if I do this, if I set a cap group, I could just do a poly bevel after it and just call it, I'm looking for something here. What am I looking for? Looking for this. Let's see, where are the cap groups? Yeah, that could work. Let's see. So let's do a poly bevel. We can throw that into a cap group and distance. Hey, look at that. Maybe 5 is good. I don't know. Doesn't really matter too much. I don't want to go too crazy with it, but just something a little bit more, smooth for these ends. Maybe like that. Cool. All right, so that they're just a little bit less hard on the ends. Can also adjust those if we wanted to, but I think we're good with those. So let's do this. It's kind of a little bit more interesting looking now. Cool. All right, I'll turn off this so we don't have our groups on. All right, so that's looking pretty good, I think. We've gotten there. And let's just see if there's anything else that we really need to think about here. Now, we could certainly start to think about coloring them, things like that. We can do that pretty easily. So yeah, let's give that a shot, I guess. So what we could do is, it's kind of hard to even say because they're so translucent. Maybe these strips are kind of lighter colored. They get even lighter at the tips. Yeah, so I wonder if we could do that here. This might be a good spot for that. Let's try messing around with that. All right. Use an alt to make a little node here so that can, oops. Shift, we'll grab all the ones above your current node. All right, let's do this. Let's do a color. I wonder if I can use this to remap the color. It's kind of the same thing as the adjust nodes, but that's what we want. All right, so we'll remap the attribute. We'll use curve U again. There we go. Cool. How is that going to work with these? Oh, yeah. Nice. That'll work nice. Okay, so let's grab this. Maybe we'll do like, actually, you know what? I'm gonna do this after the fact because this other side really doesn't need to have um, these don't need to have that same color. These can be a much lighter color because we're going to use um, probably just use a straight color. No, we don't need to ramp it or anything like that. I think it'll be fine. So let's do this, and we'll do the root. Let's open this up. Oh, you know what? There's like a sand one I want to say. There we go. Sand. What does that look like? Garbage, kind of. No, no, that's actually pretty darn good. That'll get us close and started. So, all right, let's grab this. Maybe this one's a little darker. Open this up. I like to use the HSV just because it gives me a little bit, quicker control of these. Let's do that. This is kind of perfect. We want this white to be right at the end anyways, so it's kind of nice. That's already kind of doing what we want. So then let's do a just straight color on this side. And maybe what I'll do with these is split the difference here maybe. I don't like how yellow that is. Let's just warm that up a little bit. Cool. Okay. So let's maybe copy this color. Just going to copy that parameter, bring it over here, and just do paste values. So now these should be that same color. And let's see what that looks like down here. Yeah, that's kind of doing it. Cool. So just something to keep in mind here, like I'm hoping to make these I'm hoping to make these grow. Like that's kind of my point here, is to have some sort of animation with these little elements. But what you could do if you're modeling these to get it even more natural looking, so it's not all polygonal like this. Let's just kind of take a quick side trip here, just to kind of talk about how to make this look maybe even a little bit better. And to do that, I'm actually going to thicken this just a little bit more, just because I think we're going to have better results with it like that. And I'll show it. You'll see why in a second. But okay, so we've got these different elements here. Let's do a VDB from polygons. So this would be kind of a VDB based workflow to get your geometry feeling a little bit more like one unit, right? Like it's one piece. So let's reduce the size of this. 0.01 is pretty good. This might be a little hard to see, but we got about 1.2 million voxels, and that's a pretty good amount. Let's bring this down even a little bit further, and that'll probably put us in a better spot. Yeah, that's definitely much better. We're getting a lot, and the reason I'm saying that's better is a little bit arbitrary, right? Sorry, let me just adjust this a little bit, because really what I'm saying is like, what I'm looking at here is how many little voxels can I see? Does it seem like it's smooth enough? Like, am I seeing the detail that I want to see in this? Maybe I need to go a little further. Maybe I need to do it 0.025. Now I'm at 30 million voxels. So anything I'm going to start to do on this is going to start to get really expensive as far as calculations are going to go to adjust this. But we can kind of play around. This will make a big difference. If I go from 2.5 to 3.5, we're going to cut this down from 30 to 14 million voxels. So, based on your computers or whatever, that's really going to kind of determine how you might do something like this. But all right, so we have this starting to look pretty good. It looks weird because it's voxelized, but so let's do, this is kind of the a little like smoothing tip. So what you do is you do a VDB SDF reshape. And what we can do from here is we'll do a two-step thing. We're going to do a dilate and then we'll do an erode. So let's just take the same one, bring it down here. We'll call this one dilate SDF, and this one erode SDF. And so what these both are going to do, oh, that didn't go in there. There we go. What these both are going to do is actually adjust the VDB or the SDF out and then in, or vice versa. So the dilate makes it go out, makes it get bigger. The erode makes it smaller. So what we can do is we can copy this parameter and just link these together. Let's see, we'll do paste relative references. There we go. So now those are linked. So if I do an offset, these are in voxels. You could also use world space units. So I'm just going to say like 2 voxel offset. And so already what you're going to see here, if we take both of these, let's do this. Let's take them both like this. And I'm just going to do a switch so we can look at them quickly against each other. So I'm just going to shift click and drag those both down into there. All right, cool. So this is the current, you know, dilated then eroded. So we just made it bigger and smaller. And so if we look at the difference here, you're going to see that, oh, actually, this is 2 dilates. I didn't do an erode. That's why. I was like, that's a lot bigger. It's kind of weird. Okay. So you want to make sure that one's set to erode, obviously. But you can see here that we're already smoothing this. This is already smoothing out, because when you make something bigger and then smaller, like a VDB like that, you lose a little bit of the detail, but it starts to help things kind of smooth and kind of merge together a little bit. This is something that's done with the fluid, what do you call it? The fluid meshing stuff from Flip, when you're using Flip fluids. So this is actually part of that. And so what we can do then as well is we can do I'll type in SDF, and then we'll do a smooth. So let's just grab this. Probably a mean value one is fine for right now. That'll get us, you know, a bit more smoothed here. You can see that these are starting to come together, and we can do like a 2 voxel radius like that. And you can always adjust how many iterations to that. Just means how many times it's going to do this process over and over. So that's a little bit more of a fine tune type thing with the iterations, and then the voxel radius can get crazy. And there's different operations. Gaussian is like blur it like crazy. It's going to get super, super soft. So that's going to be like the most extreme type of thing that you could do. Mean is a bit less. Mean and median are a bit less. And then these, I believe, are even less. But they might go in order of calculation time too. So just keep that in mind. But a lot of times that's how they're ordered. So anyways, let's do that. Actually, I kind of liked the way the Gaussian looked. It was pretty smooth looking. It's kind of cool. All right, let's do that. And I can probably actually adjust how many voxel. No, let's do this. And maybe we'll just do 1 iteration of it. 2, something like that, maybe. Yep. So obviously I could up the resolution of this thing too to make it a bit better. This stump is a little bit, so let's, maybe we can just subdivide that too, just to call it something a little bit more interesting here. So we don't have, so we don't have so many little polygon faces that we're seeing there. So let's come back down here. And let's switch it over, because that's not the smooth one. It's like, that's weird. Why does it look less smooth? There we go. That's looking a lot more smooth. So you can see here, this is how you would make, you could use something like this to create a much more smooth, kind of well merged together geometry. You're getting these nicer kind of softer edges here. And you could as well, we could make this polywire a little bit wider. So let's say we did it like 0.35. That's going to push the edge out a bit more. So that's going to make those individual little veins a bit more raised, but you can see how they're still blending together pretty nicely. And then if we just want to do a convert VDB, the end here, we can convert this into whatever we'd like. We can just do polygons. That's going to make obviously a lot of polygons, because we got 2.8 whatever million. So you can do some adaptivity just to kind of cut down on some of these, flatter areas that it doesn't need to have such dense amounts of polygons. But it does kind of make a little bit of a mess here. Oh, that's stronger. I went the wrong way. Um, so maybe something like that is a reasonable place to start. And then you could always use like a poly reduce, which is a really great node, and that'll give us a little bit cleaner results. It'll analyze our geometry, and we can say keep 25% of them. We'll do some calculation here. And there we go. Got quite a bit less polygons, but it'll try to still keep the quality of them as best it can. And you can also do something like this where you do like maybe 50% and they say continue reducing within a quality tolerance, and you can just adjust this tolerance. So like these are pretty small, but like I could say 0.07, and now we're kind of adjusting based on quality and not just kind of arbitrarily. So that's another thing that you could do as well. And there is this equalize lengths as well. So if you wanted it to be a bit more regular and not so stretched in some of these elements, it's going to calculate this. There we go. And so then I believe if we adjust this, it's going to try to make these a bit less chaotic and a little bit straighter. So it'll kind of do a similar process to what the VDB the convert VDB was doing, but with a little bit better quality. So anyways, just something to keep in mind here that you could do with this. This isn't exactly how I'm going to do it because obviously this process takes a while to do all this kind of manipulating. So this is much faster here to be able to work with, and we can actually make these animate a little bit quicker because the calculation time is a lot less. So we're going to try to do that. See if we can't do that. Okay, cool. That's good. Let's try this. Let's do a null here because we're going to copy these. So let's do this here, and we'll just say out mushroom. I'll just say fungus because it's not really. We'll just call it a fungus. Hit C to bring up our colors, and just so I can get a good visualization of what we're doing here. Cool. All right, so we've got our fungus. It's huge right now, but that's okay. Let's do our geo tree here. And instead of this grid, let's do an object merge. Drop this down. I'll just see what this does first of all. So let's copy this geometry. Right. I got to set it. All right, so let's grab our operator that we're going to look at here. So this is going to merge in this geometry. So let's select our out fungus, hit accept, and now that's coming in. Yep. I was like, why is that not doing anything? Missed one step. Okay, so that's coming in. Here's our copy to points. Yep. All right, so let's do some other things here. How many is this? Okay, yep. So the best thing to probably do here would be to pack and instance those for right now, just so that it'll calculate this a little quicker. What that's basically saying is that we're going to take this geometry, pack it, which means basically save that geometry data and basically store everything in one primitive. And then we're going to use just points after this. So you can see here there's 150 packed geometry. So it's packing the geometry into it, and there's just 150 geometries now. So this whole thing is all one geometry. And it's just a way to save memory and calculation time and things like that. So let's take this. Maybe we'll just do the match size with it. Oh, that's right. I had done that with the grid because it was a little different. Okay, so that's right. It's going in this blue axis. So let's do a rotate or a transform. There is no rotate node. There's a transform node though. So let's take this and we can keep an eye on that one there. And let's just rotate it like so. And we can just do it -90. Let's see where my wife my wife just handed me this water bottle because she can't open it. It is pretty tight. That one was actually tight. Usually it takes no effort for me to open them, but you're welcome. That time it did. That's funny. Anyways, all right. So the reason I adjusted those was because with these attributes here, they're pointing in the z-axis. So in this case, I need these pointing in the z-axis as well. And let's think of this as well. I think we're going to want to rotate it down like so, because I think we're going to want them to be attached here. So let's do that. Oop, forgot a 0. Okay, that I think is going to be good. So let's try that. I think it's right. It's just they're too big. They're just too darn big. Let's maybe do this. Let's try a scale to fit and see if this does anything better for us. Also we want it to be, let's do this. Because we're going to want it to be at the origin. So let's do it. Oops, wrong one. Just kind of manually set that so that it's at the origin, because it's not going to be the easiest thing to calculate that right now. So we'll just do that. Cool. That's the nice thing about the match size is that there's these little offsets that you can adjust it within the boundaries that you're moving it. There we go. That's looking a bit better. Cool. All right. So we have all of these little guys here. And we can adjust their spin amounts. I didn't go through this actually, so let me just look at this real quick. So here's our trunk geometry, right? I painted an area on it where I want these geometries, these mushrooms to go. Then I scattered here, just using points, and really just added the p-scale attribute in. And then from here, I added this instance attributes, which is a labs instance attributes node, and that gives me control over these orientations and things like that I can mess with. So from here, then I can see all these different rotations and things like that of these mushrooms. Let's see how this works. Actually, they look like they want to go out more so than down. That's interesting. So we can do a few different things here, I think. So so we can do that. Although, okay, so this, I'm actually gonna look at something a little bit different here. So this instance attributes is really nice for when you only have points, but since when you have scattering points that you've kind of been given and you want to add attributes to them and you don't want to change the points, but we're kind of starting from scratch here. So let me just try another thing here. We're going to do align, scatter and align. This is kind of a little bit of a different node, but it will do more or less the same. So this node we can do coverage. We'll do 1. Set that. Scale by attribute. Let's just see if we do mask. Is that going to give me them? Oh, there we go. That's because the scale was too big. So this node can be a little tricky because the scale actually drives the point like creation. So it's a little bit weird in that sense. So, okay, so we've got our points here now. And let's do this. Let's turn down the relaxed iterations a little bit, because what this is going to do is it's actually going to make it so that they're maybe not so smooth on top of each other, right? So this is basically going to make sure that they're a little bit apart, but not like uniformly, like kind of pushed all over the place here, where these are all kind of really uniformly distributed. So this will just, you can see how it kind of is pushing them apart. So one is good, maybe two. We can kind of play around with that. Okay, so now from here, we also have orientation attributes. So you can see here that these are all now kind of oriented a little bit differently. Let me just see if this actually even needs to be like that now. In fact, it doesn't. So let's turn this transform off. We don't need that. Let's look at this match size here. And let's just turn this offset. Let's just center these again. And do this one minimized in Y so that it's the lowest part is going to be at this plane. And we can adjust it that direction a little bit. Great. I think that'll be right. We'll play around with it, see. But, oh yeah, that's looking pretty good. Cool. All right, so this might work a little bit better. You can see that the points, it's a little strange. Why are those not? Oh, okay. The pivots. I'm seeing the pivots here, and I was trying to understand why the pivots were right here. But the reason is because this is actually, when it's packing it, it's changing its pivot. So we can just say origin instead, and now those blue dots are the points that these are packed into. So all right, we're in good shape. Just trying to figure out what was going on there for a second. All right, so we can play around with the scale of these. Obviously, they're going to get bigger, right? So as they get bigger, they're going to not want to overlap each other. So this is where this having this target size can actually be a bit helpful. So I should be able to do it like adjust the target size here to kind of control, the kind of where we want. So probably like 1.5. So this will make sure that they stay pretty well separated and they don't overlap each other. And this scatter and align is going to look at the size of these P scales on these points and say, okay, we're going to make sure they're not overlapping. In fact, you can set these here as well, and they'll just remove any point that's even slightly overlapping, but we'll be fine with that. So cool. So now if we adjust these, this will change the minimum and maximum size. So maybe the minimum is 0.5. The maximum is like 1.5 maybe, or that's probably way too big. So let's do 1.25. I don't know, something like that. We can always adjust this coverage and try to pack some more of these in there. Might not exactly be what we want, but we can do that. And then we can also take the orientation here. So now we have this random cone angle that we can adjust here. So we can kind of give it some randomization here. But let's also figure this out. So we have some initial things to set up here. So we can set up the normal direction, the forward direction, and go from there. So this here rotation around the normal is going to give us this rotation here. So we know that these are facing, let's do negative 180 and 180 like that. So now we've got just random rotations around those normals, right? And from there, we can adjust this random cone angle and get them to kind of all move around a little bit here. So that's kind of interesting. So let's see. So we can also just offset all of their angles like this, right? So we can give it an offset and then kind of adjust it however we might want it to be. So, we can just kind of play around with these a little bit like that. Maybe that's looking kind of interesting. Just going to make a merge node, alt click here for a merge node. Yeah, unfortunately those are going through. So there's a little bit of trickiness here that I might come back and try to think about a little bit more. But got a question for people who do only still renders of either environment or characters. Is it really a good idea to add Houdini to their skill set? Yeah, it's a good question. Okay, so you're doing still renders of environments and characters. Well, I'll say this. As far as environments go, the Solaris tool sets are really, really nice. I would look into that if you're interested in doing environmental layout. A lot of studios are moving towards using that to help with their layout departments and things like that. So that's a huge benefit. Now Solaris is the USD based portion of Houdini, and that will basically author USD in the background while you're laying out your scene and scattering things and stuff like that. Similarly to how I'm scattering right now, you do the same thing with USD assets. It's actually even in some ways more efficient than what I'm doing right now because USD assets are can be quite a bit more efficient. And like, so for example, if you were doing an environment like I know that Toy Story Toy Story 4 was like a big USD. That was one of their movies that they did a lot of USD on, and they set up all of their scenes, all of their layouts in Houdini using USD, and could do things like, have these gigantic scenes that you really couldn't have in individual workstations without being able to use something like USD. And really right now, I would say that Houdini is one of the kind of front runners with USD technology right now. Other people have it, and they certainly are developing it more and more. We just kind of got in really early with developing the Solaris workspace in Houdini, and so I think from that standpoint, environmentally, yeah. Characters, I mean, we certainly have great tool sets, and that's one of the things that our company is focused on highly is character work, basically getting better and better character tools in our scenes. So the other really nice thing with Solaris is you can do all of it's really made for lighting, look dev, and rendering. So, layout, lighting, look dev, all that kind of stuff. So you do all your lighting. You've got a lot of really nice lighting tools in there. And you also have, what's the word? Oh yeah. You've got the renderers right in your viewport. So any render engine that supports USD at this point pretty much has a viewport renderer in Houdini, and they actually all use common lighting. And so the lights are just kind of ubiquitous between each of them, so you don't have to switch them or anything like that, which is really nice. Shaders you would have to, but things like that. So yeah, I mean, it's an interesting question. I really appreciate asking it. Yeah, so I think maybe is the answer. I'm not going to say that in every situation that it would be the absolute, any silver bullet answer, but I think that if you're doing a lot of very varying things, it can be pretty strong. I mean, there's a lot of different stuff that you can do in Houdini, and yeah, so hopefully that sort of answers your question. Thanks for asking, and thanks for watching. So I appreciate you coming and checking out the stream, even if you might not be a Houdini user yet. So it's cool. Cool. So I'm not going to spend too much time on this because I still want to get the growth stuff going, and I'm just thinking about what the best way of doing this is. There's a few different ways we could orient these objects and do things like that. So there's no reason to really worry too much about this. Anyways, so that's starting to work. We're getting that working. We just have to tweak a few things. So we're getting closer with this. Now the thing that I want to do here is let's go into the mushroom and yes, exactly. It's huge for doing that type of stuff. Here, let me just grab a quick um, video here from the website. Let me just pull this up. So if we go to, let's say here, and oh, right. Let me just do Solaris. So Solaris. Um, so like this video here, I'm just gonna copy this link address. This is kind of a cool video to take a look at. And yeah, so I mean, there's always new stuff happening with this. So take a look at this. I mean, we support RenderMan, RenderMan, Arnold, Redshift. I think V-Ray. Not sure about Octane in Solaris yet. I don't know if they've done that, but we support a ton of third-party renderers, so there's lots and lots to do there. So yeah, great question. Appreciate it for sure. All right, so yeah, no problem. Thanks, 21 Shooter. Thanks for joining the stream. Um, all right, so let's think about how we can make this thing animate now that we've seen sort of where we're going with it. And I actually just had an interesting thought. We could maybe, I was thinking about how you could have all of these individual elements growing and stuff like that. And if you did it with each individual little fungus live, that could actually take a lot of calculation and things like that, which could be fine. We could certainly make that work. But there's a possibility that what we could do, and I'll have to think about this as we're going to make a cache of the animation of say it's 20 frames or 30 frames, however this thing grows as we're kind of getting there. Cache those files out and then play back that cache with various randomizations as we kind of scatter that and drive that in that other scene so that we don't have to copy all of this animating geometry. Oh, yeah. Right now what we're working on is just I'm doing some procedural modeling. So this model was just done with basically in Houdini we can add attributes and things like that to models. And so we're using different attributes on the points and the primitives, polygons, things like that to drive this object here. So we have all different parameters that allow us to change the way that this little mushroom is being made. So we can kind of take this and just tweak it, do all sorts of different things with it. We could also change like the scale of how this goes, so we can just kind of adjust these down here like that. So lots of different things that we can sort of do here to tweak our to tweak this little kind of fungus thing that we're creating here. And also we could randomize it so that we get different results, randomly using different seed values and things like that. So yeah, that's what we're working on. I also didn't color this, so I'm going to color this right now, and I'm going to color this the same as this edge color here. So let's grab that. Here, color, grab this. Oh, it's just white. Okay, easy enough. Maybe I won't totally make it white. We'll do something like that. All right, so we got the little stump colored too now. There we go. All right, so just thinking about how I want to best do this. Okay, so I'm going to turn a couple things off here for right now, just that. So we can have this be a little bit more performative. So instead of merging here, just thinking, sorry. All right, I'm going to turn these off here, turn this off here, so that we're just kind of dealing with, in fact, I'm going to turn this off and this ray. We don't need to worry about that right now. So I just want to try to kind of minimalize what we're doing here so that we're not having to do too much. In fact, I might just look at this for right now in order to just kind of see. I'm going to put a null down here and oops, drag that in there. I'll just call this veins, or like vein polys, so we know those are like poly wires. All right. And I like to color my intermediate stuff yellow for whatever reason. Don't know why. Okay, so we want these to animate in some interesting way. So maybe we'll have these like animate from this point here and have them grow around like that. Probably that makes the most sense as far as the way that we're doing everything else here. Yeah. So, there's actually, on the side effects website, there's a section where you can find a bunch of different learning paths. If you want a good beginner tutorial, and there's actually a thing called Houdini Foundations, which is a pretty cool way to kind of start to like build kind of a base level of understanding of what Houdini is. So, I believe if you search that, you might be able to find it. Let me see here. Learning paths. Just want to make sure I'm going the right spot here. Yep. Yeah. So this one is this is a good spot for sure. So here you go. That's honestly, there's a lot of good information in there. Not only um, there's not only stuff from side effects from Rob McGee, who's been doing all this stuff for a long time. He talks about a whole bunch of different stuff, modeling and all different stuff here. But then there's also a lot of things down here that are really good, community based stuff. CG Forge is really really cool stuff. He gets some beginnings there. Houdini isn't scary. That's a kind of a good one. Bunch of different stuff. Here's some projects and things like that. Obviously, these are going to be a little bit more maybe intermediate and stuff like that. So, and if you're transitioning from other things like Maya or, I guess maybe just Maya, Softimage. If you're using Softimage, I don't know anymore, but yeah, so some Maya stuff here. And Matt Estella's CG Wiki is amazing because he just basically dumps his brain there whenever he's learning stuff. So always a nice thing to check out. So, oh, that didn't go to Twitch, did it? Huh, that's weird. Let me try this again. There we go. For some reason, it didn't go to Twitch. Sorry for double posting for everyone else, but. All right, so let's tweak this and get some animation. So we're going to obviously work a lot in this before we're doing any of these, more. Before we're doing anything that's adding a lot of geometry, we're going to do the animation there, because we don't want to be working with tons of animated geometry or tons of geometry and trying to animate it all, and then maybe it's moving and doing some weird stuff. We kind of want to use these base curves to do our animation on, because this is the root of where everything else is going. So like, for example, here's our resample. And what we could do up here, we could actually animate these when they get to this copy to point, because we have this p-scale attribute, right? So we could take this and let's do something like, let's do an attribute adjust integer. And let's set up some, because right now these are just working on this curve, right? So this curve, each of these points are holding these attributes. So I'll pop this open maybe for a second. We can take a look at it. So in this case, we're not going to set variant. Let's do a start frame attribute. And we'll do this set initial, and we'll do, we can do a remap attribute, because we're going to use the curve view that's on this one right now, that's on this polywire. And so we can start with that curve view. And the reason I'm using these nodes is just to kind of avoid having to do any, wrangles and things like that, just to maybe keep it a little bit higher level conceptually, and you don't have to worry about coding and missing, semicolons and stuff like that. So, okay, so we got our curve view. Now we have this minimum and maximum value, and we can visualize this. Let's do start frame, and fortunately that's going to try to visualize it as a color, which isn't going to be super helpful. So let's change that to a marker. And if we come in here, make that a little bigger, we can change the font size to large so we can hopefully see that. Hopefully you can read those a little bit. So here you can see we're going between 9 and 0 for the start frame. So the other thing that we could do as well is use it like as a float and have them fractional frames, but we're animating in full frame, so it's not really gonna do too much. It's not gonna benefit us very much. So let's do this. Let's do this between maybe like 6. So we'll start at frame 6. We'll give it like a second before it starts, or a half second. Sorry, quarter second before it starts animating. Math. It's 9:30 at night, and my brain's not doing math very well. And then let's do maybe 30. So that'll give us a second here. We'll have a few that come each frame, but you can see here, these are going to be the start frames that they're going to start on. So this one will start at 6 and all the way around to 30. So that's good. So now what we could do is we can take that start frame, and in this case, I will do a wrangle because this is going to be probably the easiest way to do it. But should be pretty straightforward. Hopefully it's not going to be too complicated, but everything else we did with just these attribute adjust nodes. So let's take this and we're going to do a point wrangle. That. Okay. So from here, we first need to get this start frame attribute. So let's do that. So let's just do a integer, and we'll call this start frame. And we're just going to set that equal to I at start frame. Cool. We're also going to want to set a width, right? So duration. Why don't we call it a duration in this case? Because we know that we're going to take that's going to start at this frame, and we don't know what the end frame is going to be. So let's just call it a duration. So we'll say, we'll set this as a float, I think. So this will be a float, and we'll call this duration. And then from here, we can just do a channel. And when we make a channel in here that isn't already made, duration, oops, there we go. So when we set duration, we can use this little button here. It'll make a duration for us, and we can set that to be maybe, I don't know, we'll make that a second as well. So we'll just do 24 frames. So we've got that going. So then what we can do is we can set at p scale. And let's just make sure we're defining these all. So it's a float, p scale equals, actually we're going to do times equals. So that means multiply it by this, whatever we're about to put after this, this equal sign. And we're going to make a range basically. So we're going to do a fit. And we're going to use the built-in frame. So we're going to do at capital F frame. So we're going to use frame. And when the minimum is the start frame and the maximum is, we'll just do start frame. Actually, I'll do this up here. I don't like doing math in a fit like that, like in a function. So let's just say, you know what? I'm going to set this as a float as well. And I should be able to specify this. This is how we do this. Yes. No errors there. All right. So then we'll do a float. We'll call this end frame. And this is equal to start frame plus duration. So now we have a start frame, the duration, and the end frame. So we'll just do a start frame and the end frame here. And then we're going to set this, because it's a multiplier. So at the start frame, we want the multiplier to be 0. And at the end frame, we want it to be 1 so that it gets to its size that we want it to. So that should be good. And let's see what happens. So let's go down to our copy to points. Sure enough, we have everything. Great. Thanks so much. Yeah, glad you could join us. Have a great evening yourself. All right, so we have our copy to points going here, and let's see if we get animation. And sure enough, we do. Look at that. Hooray. So that's working fine. I did want it to go the other way, so let's do that. So we can just change the source range here. We just flip this, and that should reverse it. Just see. Bloop. Yep. Cool. All right. And then that should kind of flow through the rest of these changes. So we should get this. Yep. So those are getting built. Great. Then this will add noise onto it, which, oh boy, that isn't going to work because it's seeing that. Yep. Okay. So we're going to have to figure that out. So the problem with this node is that it's reading that there is actually a second point there. So, because here it's actually seeing that there's 2 points. So what we could do, let's just try this. Let's do a fuse. So a fuse will fuse points together that are close to each other. So we don't really need it to be this. And let's do least target. Let's see if this works. I'm not sure if this will work or not. Looks like it might have. Oh, there we go. I was just angry about that. Okay. I think that's good. Let's just see here. Yep. Okay, that might work. Let's see. See how this. There we go. Kind of interesting. Got a little growth going on there. So then what we can do here is we can adjust the duration, right? So we could have these go shorter or longer. So we could have this go, I don't know, 6 frames, and it's just going to kind of like that, shoot out. Or we could do 12, kind of get somewhere in the middle. Something like that. See how that does with this polyloft. I'm not sure. Yeah, it's pretty much working. Cool. Fun when things work. So, what we're doing here, just as a reminder, just like so we can talk about this just again, just so that everybody's kind of understanding what's going on here, is this point wrangle is adjusting the P scale. This copy to point is adjusting the scale of um, this just 2 point um, polyline right here. And then this resamples it. So this is adding in these intermediate points. And then what I was actually doing here with this fuse, which probably we could have done that up here actually, I think. Yeah, that's probably actually better. So the fuse is just making sure that when they're down like this in their scale of 0, that there's not 2 points here. There doesn't need to be 2 points. Like when we're right here in this copy to point, we're copying a line with 2 points. So when they're both collapsed on top of each other, and so we're just fusing them and taking the least point number. That's basically what we're doing. And so in that case, the least point number also has, um, you know, um, a curve of uh, no, sorry, it has a P scale of 0. Doesn't really matter. It's not using that, I guess is what we're getting at here. So um the resample's happening, everything's good there. Whoa, that's a little crazy to look at. There we go. So those are all expanding, and then this point VOP is just deforming these up. So we're getting this kind of bowl shaped thing going on here. So that's cool. Like that. I think it's working out pretty well. Let's minimize this. So now here's where the trickiness starts. So let's see what actually can animate in real time. Okay, well, that's good. The ray is not taking much time at all, so that's cool. And the polyloft is very quick, which is great. I have a feeling this thicken is going to take a little bit of time. So let's see what happens here with this. Eh, it's not the slowest thing in the world. Can't believe how stable all of this has been. Honestly, I was expecting there to be something a little bit more problematic with it, but man, it's been pretty darn stable. Amazing. And I don't mean Houdini. I just mean like didn't screw anything up when I was putting it together, and on some level. So let's see about these. Let's see if these poly wires, how these are gonna do. Yeah, I mean it's not fast, but it certainly is not the worst. Yeah, that's definitely the slowest part is this poly wire. Probably that and this thicken is definitely going to be, yeah. If we don't have the thicken or any of that stuff, it's pretty much all, um, gosh, it's like all real time almost. So that's kind of cool. Um, oh, the other thing we didn't really play around with was the start frame here. So let's see if we did like that, how that would look. It takes a little longer to build. Could do something real quick. Just do it like this. Yeah, don't like that as much. Um, let's do that. And again, let's do the duration here. Let's try 8. That's kind of cool. Nice. Okay. So With all of that in mind, now we can maybe make this animate a little bit more interestingly with more of them at the same time. So let's think about that. Okay. So I'm trying to think if the best way to do this is um, using like a for each loop over, you know, over different points basically, and have each of those points actually be a root. Excuse me. Have those each have attributes that are driving when these animate. Um, so that's a possibility. The one thing I would want to do though with my for each loop is make sure that it's um, going to be able to calculate quick enough. So one thing you can do with for each loops in geometry levels is to we can make sure that they can compile. So let's see here. This is what I want to see. So is there anything in here that's not compilable? I'm just gonna make it large. And there we go. There's the one not compilable. Oh god. Oh, that stinks. So what compilable means basically is that you can kind of take the network and turn it into like almost like a logical, sort of like one logical step in a way, like where it's like a process that happens all at the same time instead of having it, sequentially. At least this is my understanding. It's kind of like if you're compiling shaders where they're like more easily run, like functions are more easily run because they're all kind of pre-calculated, and it knows this whole process that it's about to go through, so it can kind of take it all kind of at one chunk as opposed to trying to do it all individually. But unfortunately, some nodes are not compilable in Houdini, and Polyloft is one of them. And that is just too bad. Well, let me think about this. So right now, if we were to take these, let's see, put them on the tree here. Oh, I'm gonna get rid of those compilable things. So if you hit D, it brings up this little network display option. I'm just gonna hide those again. We don't need to know. Actually, you know what I can do? I can just do normal size, so they're not obnoxious. They're just little tiny things. Okay, so we've got these. Let's just see. Oh, that's funky. So because I'm because I'm using this match size here to scale them, it's actually trying to scale them in. Oh gosh, that works pretty darn well, actually. Hmm. So let's just do this instead. I'll just do a straight transform node on this. To get this where we want it to. So let's just look at this again over here with the tree. Just change this random cone angle because we don't really, doesn't really seem to be doing us a whole lot of good there. Cool. So Just trying to think what our best way of adjusting this is. Mm-hmm. So in this case, we're just bringing in one object, right? And oops, that's not what I meant to do. So we're bringing in just one object and we're copying that. And that's why it's being fast when it's like animating in. Now, what we want to do is have them all be sort of random. Oh, another thing I should probably do just real quick is add a normal, add some normals to this so that it looks good when it's getting copied around and stuff because it looked a little funky. So let's see what that looks like now. Oh, it's the wires. I see. It's the poly wires. That's what it was. Okay. Anyways. Um so instead of doing this, let's take this. We'll do a null here, and I'm just gonna call these fungus points. And we can bring that over into our mushroom here. Do object merge. And I'm actually just going to take that out of there so that we're not making loops of things happening here. So let's just say get points. And then from the tree, fungus points. So there are our points. So let's do this for each point. And what we're going to do is we're actually going to just use this at the bottom here. So this right now has 115 that it's doing because we don't actually want to bring those points in per se. Here, there's a, okay, so this will just let us loop over these points here. You could also do it this way as well. Oops. It's technically a way to do it as well. So either of those ways work. So So what we can do here is, let me bring this over actually. We'll just kind of slowly put this into this for each loop basically. So let's take this first of all. And what we can do is, instead of having the center be there, we can set the center to be the center of those points there. So here's the first point coming in. And so what this will do is feed one back at a time 115 times. So this will feed 1 point at a time. Just pop this up here. And this has all the attributes and things like that on those, on each of those points that were coming in. So we can take this. I feel like this is becoming, I don't know, I'm just like working through this process in my head and it's feeling like it's too complicated for what I want it to be. So I got to think about this a little bit. All right, let me go grab a beverage real quick here. Take a break for a second and I will be back and we'll keep trying to work through this a little bit. So I'll be back very shortly. See you in a few minutes. Be right back. All right. I am back and even got a little snack. So, I think I'm realizing what I was doing that was kind of stupid. And so hopefully I can adjust this and make it work much better. So, here's what we're going to do. I am going to take these root points, and we don't actually need a for each loop. I don't think. We'll see, but I don't think we do. So let's take this. We're going to do a transform. Because I made this a little bit smaller, these points are like, I probably should have, anyways, it's fine. We'll be fine. We're just going to make this bigger so that it's the same scale, right? So now these points should be at the scale. Where'd they go? There they are. Should be at the mushroom scale, basically. Because we were reducing this. Actually, let me just double check. What did we reduce this by? Let's say a quarter. Okay. So we want that to be 4 times. 40 times. I don't know. Let's just see where this goes. Anyways. Sorry, just this is what you get when I'm doing it live. Okay, so let's just keep it the same size it was. That's fine. Let's take this circle, this whole setup here, and we're actually going to copy this first to points. We're going to copy this to these points. So let's, because we have the orientation, everything set on those, let's do this. Let's take, we'll do a copy to points. That's the geometry we're going to copy. We're going to copy this to those target points. And so now, yep, that's way smarter. So now we have all these little curves on here, right? And so now these can be the basis for our, for our geometry and stuff like that. Also, of course I could do this. Could do the same thing with this, just copy this into here, and now we've got those as well. So we've got these little stumps, we've got these curves here. Yeah, just makes so much more sense. And I can pack and instance those, makes them much smaller. Great. Okay, I'm just gonna, actually, you know what I'm gonna do? I'm gonna just make a copy of these so I don't have to have multiple of them flying around here. So that's fine. Great. Okay. So we've got those in there now. So now we have all of these individual curves, right? That all have a bunch of points on them each. And we could then feed this into these copied points. And now obviously that's going to be gigantic. So let's make this length a little smaller. Can make this work. .05. The interesting thing actually is that the resample is not going to work because that's too small. So let's do, yeah, that seems pretty good. So this is going to fuse them together, but oh, I'm too far. That's right. So if we look at them like this, they're all growing now. Yep, cool. So we're getting somewhere. So now what we need to do is just offset, so this is just 2 copy to points, basically. We've copied to points once and then copied those things to points again. And this has orientation information, all that stuff on them. So that's why this is working. These points that we made from the tree have all that information on it already. So now let's randomize those, right? Let's make those sort of random in some way. So maybe let's do this. So we have, let's see what attributes we have on these just so I can think about this. So we have branch ID, curve view. Let me just do this so I don't have to hold down the middle click. Branch ID, curve view, mask, the mesh noise. Not sure what that is. Oh, that's from the tree. P scale, start frame, tag, up, and UV. So what we need to do is add to the start frame, basically. That's all we need to do, more or less. So let's do this. So we have all these points here, right? But we don't want to add, like, for example, in this case here, say we wanted this whole group to start up here and slowly build all the way to the bottom. We wouldn't want this point here to get an earlier start frame than this one, because we actually want this to start first. We wouldn't want to be adding to this start frame, and not like it could really mess it up if you're doing it just based on the points. So we want to actually add the new start frame to the entire primitive, right? We want to do it to the whole element and not do it, per individual point. We want to do it to the whole element and add that whole, start element into it. So we could do it that way. We could also do it here as well. We could do, so we could do a couple other things here. So we could actually do that on these root points, now that I'm thinking of it. So that actually is the smartest way, because we can have this flow all the way through. So let's do that. Okay, so let's do an attribute adjust integer. So we just have integer frames that we're adding. We're not adding fractional frames. So let's do this over a line. And this will give us, it's kind of a fun little thing. This is sort of, feels like, if you're familiar with like Cinema 4D, it feels a little bit like that, where you get like you get your fall off values and things like that, or at least kind of how they used to be. This, So, okay, so we're going to start up there, and we'll have this maybe travel in a line down this way. So we'll have it there, put this up here. So we'll start it up there and have it move down. So this will get 0. We don't need to add any frames to these up here. And then down towards the bottom, we can kind of set that however we want, but we can do that couple seconds maybe. Maybe we'll do 48 frames from there. So right now this is setting variant, but instead we can do start frame like this. And let's just double check that that is doing what we want it to. Oh, darn it. I did it the other way. I can just flip these, I think. Yep, there we go. All right, so that's the adjustment that these are all going to get to their start frames. So let's maybe bring this down a little bit more. You can see that these are going to get adjusted, maybe by 1 frame there, and all the way down to 42 at the bottom here. So kind of adjust those. Cool. Great. So now on this copy to points here, because these are going to now have those copied start frames. So they're all going to want, let's just so you can see this happen. Okay, so they all had the same start frame. So let's have that added in here. So right now, let's look at these here. These 30. Okay, so that's why that's happening. All right, because we're doing the P scale at this point here. Um, it's not exactly going to work the way I was thinking. Okay. Okay. So what we should be able to do is take this down here, and that should basically work the same, I think. Question mark. Let's see. So now the animation's happening here, and I think we're going to see what I was thinking was going to happen before, which is, yep, for sure. They're going to be growing. So now they're all just growing like that. But that isn't exactly what we want either, because we want them to scale up the same way they were before, kind of radially, but have that flow down. So this, okay, so this is what I was saying before. So now we can take, sorry, a little thing popped up. Now we can take this, and instead of these all being the same, like 14 in this case, and this one's 15 here, we can add them together instead of copying them. So in this case here, we can say these are the attributes that aren't. This little caret here means not. So what we'll say is comma not start frame. And then we will do v and do start frame. So this is going to apply to points by adding. So it's going to add them together. And sure enough, I think that may have just worked. So now it's 42 and 18. Yep, that looks good. Let me turn these off. Turn the points off so we can see these. And let's see what happens. Yep. Now we're getting those all grow out like that. So that's working the way we wanted it to. Cool. Make sure that's together like that. Yep. Kind of freaking out for a second there. We'll have to fix some of this. But I just wanted to see if the stumps would get copied in there. They are. Cool. All right. So this is now an issue, this point fob. The resample should be working just fine. Everything looks good there. Let's see. Yep. So we've got all these individual points. Everything's looking good. Pretty quick. I mean, it's definitely slowing down, so we'll probably want to cache out this animation. But up to that point, it's all pretty quick. You know, the animation, you can see it play back in real time. Just that we have a lot of primitives at this point now. So we've got some 5,000 individual lines and 185,000 points. We could make this a little longer if we wanted to, maybe, but you know, you're just going to lose some resolution there. So that's kind of up to you, however you want to do that. But those are growing. It's working. Cool. Okay. So in this case here, we have this point fob, right? And what this is doing is taking the second vector component and adding it's adding some noise and multiplication and things like that. So it's basically all working on just the y-axis, and we actually need it to work on all of the axis. Or we could just define what that y-axis is, right? We don't have to just take the up and down y-axis. We can figure out the axis that's pointing away, away from the tree stump. So let's take a look at that. See if we have any attributes that are going to give us that. Hey, look at that. Sure enough, we do. We've got a normal attribute. So if we use the normal attribute, let's just double check here and make sure that that's still the case when we get down here. Oh, see, that one actually doesn't have the normal attribute. So let's Let's copy that normal attribute. So we're going to take out normal out of there. So now we should have those normals copied. Perfect. That's what we wanted. So now we have this point wrangle, and we're going to take that normal out again because we want that normal to continue on through. So now we have those normals on those. Great. So fuse, resample, we still have the normals. That's good. So now in this point fop, what we could do is instead of doing this where we're getting the vector component and adding to it, what we could do is do a displace along normal. Let's see if we can get this to work. So we'll take the point position and the normal, and then we should be able to, instead of doing this, we don't need to do this. We can add those together. We don't need to take the point position. So what we can do is we can use these. These are both going to be, just going to hit R there. These are both going to be our kind of our amplitude basically for this. So that's what we're going to get right there. We don't need to do this vector set component anymore. And what we can do is we can do the sum, and we can do which one's which? I think we can do displacement amount. And then we can do this. Yep. Cool. It's working. It's just too big. So and we'll probably want to adjust the frequency as well, but we're getting somewhere here. So let's just turn both of these down quite a bit. So we'll just turn all these all the way down, and we can kind of start to figure out what these should be because we're working on a smaller scale now. So let's do something like that. Maybe like that. Cool. Yep. Looks good. Maybe we'll do 0.005, something like that. So what we need to do is we need to turn the and we can promote all of these as well. I'm just kind of, we could do that. Actually, we could just do that right now. We could just do promote that parameter, the frequency. I don't think we need anything else. Frequency will be fine. So let's just adjust this, and we can get a much, oh, I think I always forget that it's actually the other way where we need a higher frequency. All right, maybe like 25 will be good there. I don't know. Let's see. Let's do 50. That seems fine. All right, let's see how that looks. Oh, what did we lose here? Sorry, we lost something else here. So we got attributed as color. Oh, yeah. Yep. Yeah, it's not going to like that. So the problem is that it's trying to figure out some, it's like calculating these all at the same time. As opposed to looking at them as individual geometries. So Let's just leave that out for right now. We'll just have to let that be. Just want to see kind of how this is looking. Doing its thing. Obviously, as it makes more and more of them, it's going to get slower and slower, but um, certainly it's working. The other thing we're probably going to do is make these smaller because those should be a touch smaller. Those need to be longer. Let's see here. I'm going to go back up to the tree. Just make these maybe a little bigger. Smaller. Yeah, that's definitely that's the slowest part right there is doing all the doing the polywire. Bevel's probably not great either, but let me see what that looks like. All right. So what we could do here is we could just do a little for each loop at this point because we know that everything else is going to work. We just need to make this poly loft a little friendlier for this animation. We know it's all animating the way we kind of want it to now, right? And so at this point, we know that we can continue doing stuff that'll, maybe we have to cash it out at this point, but we know that it should work. So let's do this time we will actually do a for each, and we'll do a for each named primitive. And what I am going to do is add a numerate up here. And I think what we could do is just say So this is going to add. This is going to add point attributes for each of these. So this says piece 0. So instead of that, we'll say fungus underscore and then have a number. There we go. So now they're all named. We'll make sure that those copy through. We'll say here, we're going to add a new, we're going to say over here, comma, not. So we're going to not do the, oh, I might not actually see that one. Let's see. Oh, index. Let's do name. No wonder I wasn't seeing it. I was like, wait, call it name. Okay, there we go. So let's do this. Name. And so we're going to apply this to primitives by copying name. So let's just double check that that's working. Sure enough, there they are. Each of these has the name of some fungus. And we can do the same thing down here by copying. Oh, let's just do this. We'll do points, name. I don't actually need that. Sorry, my bad. We'll just do this. Start frame here. So we should have the name on all of these now. Let's double check. Yep, name fungus. Yeah, great. So then down here, same thing should happen. They should come right through with the name. There we go. There's the name on all of them. And then now all I need to do is set an attribute promote because I need it on the primitives for that for each loop. So here I'm just going to promote it. Oh, in fact, I could do that right here. Duh. Primitives, attribute, name. There we go. Oh, I guess I didn't have to do it not here because I don't have a name. Okay. Guess I didn't need to add it to this list. Just adding it here is fine. So anyways, now these should all have it. Great. So now each of this, there's 21, and each of them is going to one at a time loop through these individual groups. So if I do a single pass here, I can look at each of them individually. There they are. Great. Doesn't really matter what order they're in. It's fine. So let's do that. Now I can't compile this, but I can do it in a for each. So let's just see if this will work now. Yep. Working. And then from there, should be able to do this. So that little for each is pretty much all that we needed right there. And if we turn these on, turn this on. Oh, I made it. It's crazy thick. It's way too thick. Whoops. Yeah, because the thicken is set too thick. Try that. Hmm. Oh, that's interesting. Why is that pulling in so far? What's going on there? Hmm. Oh, there must be a. I wonder if there's a tolerant. This tolerance thing is set too low, maybe. Yeah, that might be it. Okay, there we go. That's the problem. That was not making a full thing there. Set that as well. Cool. Great. Now we should be all set. That's good. Thicken. I'm just going to take the curl scale down just a little. All right. So we don't need this copy to points anymore because we're doing that on the other side. There's our fungus points. Could have actually done that probably in the top of the other node, but that's fine. And so here's our trunk geo. Don't really need this anymore. Fungus points, great. All right, there's those. They're growing on the tree. All right, so what I'm going to do is this is going to be our fungus. So let's put a file cache down and we'll kind of wrap this up here. So I'm just going to cache this out just so that these doesn't have to calculate this every time. So let's set this up. We'll just call this fungus cache. We don't need to have the hip name in there. That's fine. Geo is good. Actually, you know what I'm going to do? I'm going to call this anim fungus cache. So we know it's animated. All right, so in this new file cache node, what you want to do is you're going to want to turn the simulation off because it doesn't matter. We're going to render it as or we're going to evaluate it as a frame range. And when we do, let's see, I just want to make sure that we can do this in a smart way. So it's time dependent, constructed. That's what we want. This is version 1. All right, so let's do this. I'm going to save this, make sure we're good. And then let's save it to disk and background. So this is going to boot up a bunch of Houdini instances. Hopefully it won't freak my computer out. If my voice starts getting goofy, just let me know. Oh, you know what? I know what I want to do. Close this. Looks like that was going to error out anyways. So let's see here. So what I want to do is actually So in this top note, let me just allow editing of this, and then I can go inside. All right, so we have this top network here. We have our geometry, and what we want to do is we actually want to, yeah, see, this actually has all frames in one batch. So I'm not sure why it's doing that. But instead, what we're going to do, instead of having one frame per batch, what that means is each individual, let's change this to 120 as well. Each individual instance of like that it starts up, all those little work items, each is their own instance of Houdini. So what I'm going to do is set it to be so that 24 frames in a chunk is going to, or maybe like 12. We'll do 12 frames per batch. And so what that's going to do then is make sure that when I hit save to disk and background, you'll see that there's going to be like gaps in between them, and it's going to load one instance and render 12 and one instance and render 12. So they're all going to be kind of working simultaneously and not having to reload the scene every frame. So let's try this again. Save that, do this. There we go. You can see that they're separated here now, right? So let's let that go. Hopefully this will all be fine. Ah, bummer. Why did that first one fail? That's weird. Why did that first one fail? So you can see here that it's loading up individual work items, right? And be mindful when you're doing this too. Like, this is using up a decent amount of RAM because each of them have to like load the scene and like calculate it. So I'm definitely cruising for, a little bit of a bruise in here. Yeah, I'm using about 67 gigs of RAM right now, but you can kind of see that it's actually caching out all these frames simultaneously across the whole thing, and except for the beginning. Why did it not do that? That's so weird. I'm gonna have to look at those. Let's see. Um, Interesting. Some stuff failed to cook. That's interesting. Let me just see if I can cook this one work item. Weird. Why would it? That's so weird. Huh. Yeah, there's no files on disk there, so I can't see them. That is really funky. Ooh, interesting. Why did it do that? There's one little error there. I don't know why it did that one thing like that, but anyways, I'm not sure about that. I'll have to look into that. But I think you get an idea of what we're kind of working with here and how, we can cache this out to disk, read it back in, and get kind of some interesting animation just by using attributes and parameters to kind of drive the entire animation. So hopefully it gives you some ideas for working with your own models, animation, whatever you might be doing. Sometimes doing an effect isn't a simulation. It's it's animation with using parameters and attributes and things like that. So hopefully it's something interesting. And I'd love to hear from you guys if you have any thoughts on that. But that's where we're going to leave it for tonight. Thank you guys so much for joining me. Hopefully you got something out of it. And next week we're going to have a guest actually on the stream. One of my coworkers, Michael, who is a who's really knows his way around characters in Houdini, is going to come in and do some demonstrations of kin effects and how to work with characters and things like that. So should be really interesting. He's way more qualified than I am to talk about kin effects. So should be really interesting. And I'll post a little bit more in the coming week about what he's going to be talking about specifically and that kind of stuff. So yeah, thank you guys so much for watching, and I hope you all have a great night, and see you next week. Bye.